Okay, hello. So we are looking at our second standard distribution for PGFs, and we're going to look at the Poisson distribution here. Okay, so we're going to kick it off with an example, and it says x is the discrete random variable such that x is Poissonally distributed with a lambda value, a mean of 1.1. Show from first principles the probability generating function of x is given by g of x of t is e to the power of 1.1 brackets t minus 1. Okay, so obviously we know that our probability generating functions are given by the sum of our probability mass functions times t to the power of x. Okay, so here we know we've got a Poisson distribution with a lambda value of 1.1. And if you look in your formula book, and I'm going from page 23 now because that's got all of our PGFs on it as well, so it's a good table to use. Okay, it's the under A level further maths. And if you look at the Poisson section, it gives you our probability mass function for Poisson. So it says our probability mass function for Poisson is e to the minus lambda to the x over x factorial. Okay, I put it all over x factorial. Obviously, in the formula book it writes it next to it, but it means the same thing. Okay, so in this case, that means our probability mass function, where our lambda is 1.1, is e to the minus 1.1, 1.1 to the x over x factorial. Okay, that therefore means that our probability generating function, which has got our probability mass function times t to the power of x, is going to be e to the minus 1.1, 1.1 x over x factorial times t to the x. Okay. Now what I'm going to do is I'm going to try to sort of tidy that up a little bit. So we've got e to the minus 1.1, 1.1 x, t to the x obviously can sit on the top, x factorial there. Now e to the minus 1.1 is obviously going to be a constant, okay, because it's not got an x in it, it's nothing to do with x, it doesn't matter. So I can take a factor, if you like, I'm factorising it. I can take a factor of e to the minus 1.1 out, which means I'm left with the sum of 1.1 to the x, t to the x, over x factorial, okay. Now I can tidy that even further and make it the sum of 1.1t all to the power of x over x factorial, okay. Now what I've got here is the sum of 1.1t to the x over x factorial. So if I wrote that out, if I substituted in x is 0, x is 1, x is 2, etc., what I would end up with is, if I put in 0, obviously I've got something to the power of 0 over 0 factorial. Well, 0 factorial is 1, anything to the power of 0 is 1, so that's just going to be 1, plus, then if I put x is 1, I'd have 1.1t over 1 factorial, which is just 1. Then I'd have 1.1t squared over 2 factorial, plus 1.1t cubed over 3 factorial, etc., etc. Okay, I'm really sorry, I should have put those in brackets. Plus 1.1t to the 4 over 4 factorial, dot, dot, dot. Okay, that is what we'd have, sorry, I hope you can see. Okay, now, this is a little bit niche, but once you see it, it's a bit like with the binomial one, once you see it, then it's okay. If you look at page 18 of your formula book, you will see at the top left, obviously we're left with page 18, at the top we have Maclaurin's and Taylor series, okay? I don't know if you've done Maclaurin's series yet or not with Miss Ball, but if you have, that's fab. If you haven't, don't panic. Okay, this here is a Maclaurin series, this second one down. It's this series here that's written, let me write it so you can see it, that e to the x is 1 plus x squared over 2 bang, plus x cubed over 3 bang, up blah 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 blah. Okay, now can we hopefully see that that is the same as that, okay, but the x is now 1.1t. Okay, our x is now 1.1t. So what we have got now is this e to the minus 1.1 is outside as a factor, and this is all the Maclaurin series, e to the x, where x is 1.1t. So that's e to the 1.1t. Okay, now obviously we've got e to the minus 1.1 times e to the 1.1t, so that is e to the 1.1t minus 1.1, which obviously is just e to the 1.1 t minus 1, and that is what we were asked to get in the first place. Okay, so all I'm just going to do is write at the end our favourite saying, as required. Okay.